Okay, here's our video on the law of exponents with multiplication, part 1. So we're basically going to just multiply exponents. We'll divide exponents in another video and add them and subtract them in another video. So let's look at an example here. We have 3 cubed, remember 3 means cubed, times 3 squared. Or we can say 3 to the third power times 3 to the second power. Okay, so when we have the same base, so here, remember, the big number is the base, and the small number is the power. It's also called the index, and it's also called the exponent. So we have 3 names for it. Okay, power, index, or exponent. So when we have the same base, we just keep the base. See how we kept the base when we're multiplying, and we just add the exponent. So we would get 3 to the 5th power. Okay, so I'll give you another example here. Let's say I had, we'll do it over here, 144 to the 5th power times 144 to the 10th power. So what do you think that answer would be? Well, they have the same base, right? So it's 144. You keep the base and just add the exponent. So 15, 5 plus 10 is 15. So that would be the answer. So again, it's important to remember that when they have the same bases in multiplication, keep the base and add the exponents. What if I had this? What if I had 2,312 to the 3rd power times 2,312 to the 3rd power? They have the same base, right? So it's 2,312 to the 6th power. Add the exponents. Okay, try this one. See if you can do this one by yourself. Okay, do they have the same exponents? No. Do they have the same base? Yes. Same base, add the exponents. Now this would be 4 to the 1st power. 5 plus negative 4 is 1. Or you can just simply put a 4. You don't have to put the 1. Since the 1, if you see no exponent, there is a 1 there. The 1's invisible. Now let's try one where the bases are negative. Well, it's the same thing. Same base, negative 5. Just add the exponents. Same base, keep the base. That'll be the answer. Okay. Now what if we had something like this? Here they don't have the same base, but they do have the same exponents. So when they have the same exponents, you keep the exponents. Now if we go back here, let's go back to the problem where we had the same exponents. So here they have the same base and the same exponents, but you always keep the base. The base overrules that. So looking back at this question, 2 to the 3rd power times 3 to the 3rd power, they have the same exponents. They have the same exponents, so we keep the exponents and just multiply the base. 6 to the 3rd power. So the second rule we should remember, if they have different bases and the same exponents, what do? We multiply the bases, and keep the exponents. Okay. So let's see if we can do this one now. This one's a little tricky because it has variables. Just remember, if they have different bases, you multiply the bases and keep the exponents. Now here it's tricky because the 2 and the 4 don't have exponents. They're really, the only thing you do with them is just multiply. You'll get an 8. The ones that have the exponents are these variables. The base is the same though, it's x. So you have to keep x and just add the exponents, and that's what you get. Okay, try this one. So the 3 has no exponent to it, and the constant that's next to this x, or the coefficient, is a 1. There's a 1 there. So 3 times 1 is just 3. So it's going to be 3. They have the same base, which is x. And remember, there's a 1 on top of that x. So it's 3 plus 1 would be 3x to the 4th power. Don't just put 3. The common mistake is writing 3x to the 3rd power, thinking that there's no exponent there, but there is. There's a 1. Only if you saw something like this, an example here. If I had 5y to the 5th power times 2y to the 0 power, right? We'll keep the 5 times 2, we'll make that a 10. They have the same base y, and now it's just 5 because 5 plus 0 is 5. But if they don't have that 0 there, if there's no 0 there, then it's a 1. So keep that in mind. That's one trick that you might find. What if we had 3 bases, or 4, or 5, and they were all the same? What do you think we would do with this? Well, do they have the same base? Yes. Remember the rule always. Keep the base if it's all the same. And they had the exponents. So we have 2 plus 3 is 5, and 5 plus negative 2 is 3. Now what if we had just variables, no numbers? Well, it's the same thing, the same concept. So here we have a b and a b. They have the same base, right? So we'll say b. Now there's a 1 on top of that b. Remember that. We talked about that before. So this will be to the 4th power. It will be b, yes. And the m has the same m. And it'll be m will be 4 plus 7. The 11th power. So that would be the answer. Now what if we had different bases and different exponents? What if we came across something like 3 to the 2nd power times 115 to the 7th power, something like that? Well, with something like this, there's no formal rule, but there's a way we can solve these by factoring. I'll give an example, and we'll talk about this more in another video. Let's say I had 2 to the 3rd power times 4 to the 2nd power. Now they have different bases and they have different exponents. But what we can do here, since we know 4 to the 2nd power is 16, right? 4 to the power is 16, we can say 2 to the 3rd power times 2 to the 4th power, because we know 2 to the 4th power is 16. And then we would get 2 to the 7th power. So there's a way of doing it when they have different bases and different exponents, but I'll talk about that in another video. And in our next video, we'll still concentrate on the law of exponents with multiplication. Great job.